Hey guys, so I'm going to do a very quick video just on the mechanism of free radical substitution. So that's the type of mechanism, and the mechanism really looks at what happens if we think of, normally we would do A plus B to give me C plus D reactants to products. So a mechanism deals with sort of what happens before we get to C and D. So A and B just don't magically turn into C and D. So they may turn into another few things based on rearrangements of electrons and electrons moving around and being lost and gained and shared with other things. So the mechanism deals with this process here. This type of reaction is called photochemical halogenation. In other words, using light to power a chemical reaction which involves halogens. So you might, if it was specifically for chlorine, you might call it photochemical chlorination. For bromine, photochemical bromination. Okay, so you just have to adapt your answer there. But the mechanism is free radical substitution. The type of reaction, which is a different thing, is photochemical halogenation. And then depending on which halogen they ask you, you'd say chlorination, halogenation, or chlorination, bromination, etc. So the overall reaction, we're looking here at an alkane. So we'll take methane as our example, reacting with a halogen. So if you use chlorine as our example, you just sub in whatever halogen it is. And the desired product that we're after is chloromethane, where we've taken one hydrogen off and replaced it with a chlorine, hence the term halogenation or chlorination, and also hence the term substitution, because we're substituting a hydrogen with a chlorine. Okay? And our byproduct is HCl. So that is the overall balance symbol equation. That is not the mechanism. Okay, that is what we start with and that's what we end with. Remember I said earlier, the mechanism now is what happens in between to get to there. So we'll look at the mechanism now, okay, and I'm going to clear this stuff. So, as I said earlier, this is photochemical. So the first step involves, this is the step which involves the light. It involves UV light. You can also run this at above 450 degrees Celsius, does the same thing. And this mechanism is split into 3 steps. And the first step is the initiation step. Okay? Now the initiation step is where the reaction gets started. So like any initiation, you initiate anything, you start it. So this step is chlorine, which is Cl2, goes to what we call chlorine free radicals. Okay? So what's happening here? Well, if we look a little bit closer at the bonding situation here of the chlorine. Chlorine and diatomic chlorine is joined as so with a covalent bond. Now this bond in this particular instance breaks the UV light, or the heat causes it to break, and one electron goes to there and one electron goes to there. So the bond is broken evenly, okay, with one electron going to each atom. That is a type of bond breaking or bond fission called homolytic bond breaking and homolytic fission. Okay? So we are breaking the bond evenly. The alternate type of fission that you would have there would be what we call heterolytic, where the bond would break and these 2 electrons here would go with this chlorine, which would give you a chlorine with a negative charge. This chlorine would be left over with a positive charge. That would be what we call heterolytic bond fission. Okay, hetero meaning opposites, and we get ions there. But this time it breaks, and it breaks evenly, and we have a radical now with a single unpaired electron. We don't worry about these paired electrons here. It's the unpaired one in the outer shell. We represent a radical as a dot. Now radicals, free radicals, as this is, okay, are extremely unstable and reactive, and we need this because what we're reacting this with, an alkane in this instance, is very reactive, so we need someone that's going to really attack it. So this is the first stage of the reaction, initiation. The next step of the reaction is what we call propagation. And if you propagate something, you keep it going. So the chlorine radical made from up here, by the way, not all the chlorine, only a little bit of the chlorine is broken down, so there's still lots of chlorine in the reaction mixture for steps that happen later on. So what happens is that chlorine radical now will of course bump into a methane molecule, and I'll just draw the methane like this and you'll see why in a second. Chlorine, and the chlorine radical is highly unstable because of its unpaired electron. It wants to get an electron, so it grabs this electron from here. You'll see I'm representing the movement of the electrons here, I should have said, with what's called a curly arrow. And that's how we show electrons moving from one place to another in a mechanism. If it's a single electron, which it is here, we just use a single-headed curly arrow. If it was two electrons, a pair, we would use a double-headed curly arrow like so. But this is just one electron moving. So if we take an electron out of a bond, the bond will break. And I now have my methane with still my three hydrogens here, but we now have an unpaired electron left. That is referred to a methyl radical now, which again is a very unstable species. And my hydrogen and my chlorine have paired up to give me a byproduct of HCl. My methyl radical won't stop there. Again, it's highly reactive. Okay, and it will bump into some of the chlorine that I said up here was left over. Okay, and again it will want to pair up and get an electron from somewhere, and I can grab one from there, and again I show a curly arrow with a single head to show movement of one electron only, just this one. And that gives me a happy chloromethane, and that chloromethane in this instance is my desired product. That's what I want to get, and now I've produced a methyl radical, another radical, and this is propagation, keeping the reaction going, and in both propagation steps I have made radicals. Now in your exam question you just have to adapt. I've got methane here, but you might get ethane or propane or something. You just have to change as you go along. You learn my mechanism and then you change what is on the chain here, and then obviously that would affect what that is, which would affect then what that is, but you just have to adapt your answer to whatever question is given to you. So those are our initiation and our propagation steps that you need to know. Okay, and all your mechanisms, if you're asked to draw them, will have one initiation. This one, if it's chlorine, or similar if it's bromine. I will always have two propagations following this pattern, and you'll then have what we call termination steps. So I'm going to wipe this board and go to our termination steps. So you will also have three possible termination steps. And termination means to stop something. So this is where radicals now start to pair up. So two chlorine radicals may well, because of the way the reaction goes, they just bounce into each other and form chlorine. That is undesirable. You don't want that, because chlorine is what you want to actually be reacting with your methane to make your chloromethane. You might also get two methyl radicals, might bang into each other, and they'll pair up to give you ethane. Okay, again, that's not really a desirable reaction. And finally, you'll get your desirable reaction, which is a methyl radical and a chlorine radical. They'll join together to give you chloromethane. Okay, and that would be your desirable step. That's what you want. These others are simply unavoidable, and you will get a mixture of various different products at the end of your reaction. Sometimes they ask you, well, what would you do with your mix of reactants if you wanted to not just chlorinate one, not just substitute one hydrogen, but maybe you wanted to get rid of all four hydrogens and go for CCl4. Well, in that case, you just add at the start of the reaction, instead of just adding a little bit of chlorine, you would add an excess, lots and lots of chlorine. Okay, and by doing so, you would end up getting maybe more chlorinated hydrocarbon, more chlorines replacing more hydrogens. Okay, so that's how you would do that, and sometimes they ask that, but you don't need to know the mechanism steps for adding more than one chlorine. Okay, so as I said, you've just got to adapt your mechanism for whatever alkane they give you, whether they give you CH4, C2H6, C3H8, etc. Okay, and you just keep changing that dependent on having learnt this template of reaction mechanism from what I've done. Hopefully that clears that up, guys, and it's a bit of help to you in terms of revising this stuff. on learning it. You can come and see me if you need any other questions answered.